Good morning, classroom. Today we have a lesson on machine learning. But first, let's go over a story on how it helps somebody.
In Belgium, there's a girl named Monique who was born with glaucoma, which caused her to lose her eyesight over the years.
Catherine, who was this inspired software and hardware developer, developed a smart camera in order for Monique to take pictures. It does so by audio and vibration signals.
She incorporated machine learning into the camera so that it could have offline real-time recognition.
For example, if the shot isn't straight, the phone will vibrate to notify her. Also, if she were to take a picture to say this eraser, the phone would say eraser. This gives her more options and lets her choose her pictures.
The camera also has sound signals, so if there's bad lighting, Monique can fix it.
Monique says, I lost my eyesight, but this has given me a new way to see. Hey guys, my name is Johnny.
And my name is Yareli. I hope Monique's story helped you understand why machine learning is useful.
Today we'll be going over machine learning and the various hardwares for machine learning, and we will also assess their efficiency. In order to understand machine learning hardware, you must first gain an understanding of machine learning. Machine learning is the science of getting computers to automatically learn and improve with experience without being specifically programmed to.
Learning begins with observations or direct experience in order to find patterns in data and make better choices.
A neural network is comprised of many small units called neurons, which are grouped in layers.
Neurons in one layer interact with neurons in the next layer through weighted connections that have a value that is adjusted based on stimuli.
The neurons multiply their value with the connections called weight.
And are added to a bias which is then put into an activation function.
It will fire its signal to other neurons in the next layer.
The weights are learnable parameters that change as the model is ran. Usually they will be set to random numbers in the beginning and find the appropriate values that allow the neuron to be fired when it needs to.
Neural networks require a lot of time to process because a lot of data is being used.
However, it is oftentimes required for many of the tasks humans or traditional programming algorithms can't do on their own. For example, the story of Monique.
For making a simple Google search to online shopping,
Machine learning is everywhere. Machine learning wouldn't be possible without its hardware. Hardware is important because, in order for a device to work at its peak, the architecture of its hardware must work in parallel with its software. Our computers have a type of hardware called a computing processor, which is a type of integrated circuit.
Integrated circuits are electronic circuits on a semiconductor material, which is usually silicon.
They contain billions of connections that allow for complicated computations to be performed. Although powerful, the integrated circuits in our computers are not specifically designed for machine learning.
Our computers do incorporate some machine learning components, but only marginally. This, paired with the non-machine learning architecture, makes our computers not suited for machine learning.
Von Neumann architecture is popular amongst many computers such as CPUs and GPUs.
It contains registers, inputs and outputs, control units, arithmetic and logic units, and a RAM unit.
A great analogy for this is having a workforce living in houses in the suburbs and having a workplace located in the urban city. You, the day that wakes up before the sun does and leaves the house RAM at 5:30 a.m. In order to arrive to work, the ALU 70 miles away with the ocean of cars you will have to be bumper to bumper with. You begin the boss's CU's task operations based on the customer needs input on the workaround's ALU and get moving quick in order to meet the deadline's output. The long day ends and you are yet again stuck in traffic on the way home. You get home and have a quick dinner and sleep early to repeat the cycle over again.
As you might have noticed in the analogy, the data doesn't live close to the ALU. Unfortunately, data movement consumes a lot of energy. The energy required to access data from memory can be much higher than the energy needed for a computing operation. Therefore, von Neumann architecture is good for general use computers, but not the best architecture for machine learning software, where millions of signals are being fired.
Actually, there is current research being done in order to commercialize more adapted hardware for machine learning, in order to unite the components of machine learning and the practicality of our personal computers.
The first of these technologies are digital deep learning accelerators.
Basically, what they are is they speed up the learning of neural networks and other machine learning algorithms by enhancing their hardware.
Let's look at an analogy in the form of a possible solution to a commuting problem offered by a company.
In this scenario, the variables represent the same things as we mentioned before.
Imagine you work for a company that offers a per diem, which is an amount of money for housing near its facility. You, the day to pack your things and move hundreds of miles away from your home RAM. You plan to live near the worksite ALU for 6 months. Instead of now living hundreds of miles away, you now live 5 miles away from the work grounds. You wake up at 7 a.m. and take the company transportation to arrive to work. Every morning, along with the other employees, additional data. You and the other employees take in orders input from the boss CU and produce a product output. The cycle repeats until the 6 months are over. You and your coworkers go home with your families with a healthy amount of cash. The other workers that spent the 6 months back home now move hundreds of miles away to work while you get well-needed rest with your family.
The machine learning hardware problem can be improved by a similar principle.
Digital
Digital deep learning accelerators support a parallel compute paradigm while optimizing the energy cost of data movement from both on-chip and off-chip.
The cost of data movement is reduced by exploiting data reuse in a multi-level memory hierarchy, namely an architecture, whose storage and computation hardware is distributed in processing elements arranged in a 2D array.
Digital learning accelerators are important because with the advent of machine learning in more and more applications, it becomes essential to develop hardware for its specific needs.
Although classic deep learning accelerators reduce data movement overhead, regular data accessing is inevitable.
With the concept of in-memory computing, we are leaps closer to machine learning's true potential. The accelerators embed processing elements into memory cells, which provide both local storage and compute.
This closely mimics the brain and its neurons. Typically, in-memory computing employs analog operation.
It enables a computation result over many stored bits, decreasing the amount of accessing energy and delay.
In comparison to the other analogies, in-memory computing is the most effective regarding productivity.
The analogy goes as follows.
You, the data, wakes up at 8 a.m. ready to begin your day. You have breakfast with your family, then you go into your home office. With a laptop and coffee, you begin to work on orders, outputs, sent to you by your boss to you in another city. You play music, which helps with productivity, along with the quietness and comfort of your own home. You finish the workload, outputs early, and enjoy the rest of the evening watching a movie with your family.
Notice one element from the rest of the analogies was missing here, the ALU. No longer is it required to travel back and forth between on-chip and off-chip that would waste huge amounts of energy and time.
Machine learning is a powerful creation that can help us do many things other programs can't do on their own. However, we have to welcome it into our devices by making it a suitable home. There has already been many commercial in-memory computing devices on the market, but it hasn't caught on.
Research is still being done, and soon there will be a new host of machine learning applications. In the future, you're going to probably end up wondering how you could ever live without it. So now I hope that you learned a little bit more about integrated circuits, machine learning, and hardware architecture.
Thank you all guys for watching. Make sure to leave a like, subscribe. If you have a question, leave it down below. This has been Johnny and Yareli.